So we all typed in this equation, negative 4.9x squared plus 50x plus 10 from the previous example. When we went to graph it, it didn't all show up on our window because it started off, if you're in a standard window, it probably started off like this, where it's just one blue line and you can't see the whole parabola. Since we know this is a parabola, we're going to need to change the window. Couple of things you can do for changing the window. There's a zoom button. So one way to change the window is to go to a zoom button, and they've got a bunch of different things. The one that is the standard window is there, but that one didn't show us everything. Another one that students sometimes like as a starting point is this one here, which is zoom fit. So if I push that, it's going to try to fit most of my graph on there. It may or may not do a good job, but you can kind of see the parabola there. If you want to change it even more, let's say I just want to see this part up here, I can go to my window button and I can change what my x min and my x max, my y min and y max are. So I'm going to do that right now. I'm going to go from x going from -1 to 20, and I'm going to change my y from -1 to 200. What's under the y scale is just how many marks that are on the scale. So if you want it every 10, then when you go to graph it, these marks that are on your y-axis represent 10 units for every mark. My ones on my x-axis still represent 1. I actually want to see more of my x-axis on the bottom, so I'm going to just change my values. This one maybe just to -5, and my y min to -10 instead, just to see a little bit more of my axes. Now your calculator can find a bunch of important information, and all of that information is just above your trace button. So if you see your trace button right beside your graph button, it says calculate. So if you go to that, what we're going to do right now is just go through what each of these things are and what they do. So the first one is value. If you push enter on value, you can find any value of x you like. So for example, if you wanted to find the y-intercept, that happens when x is equal to 0. So you put 0 in for x and push enter, and it finds the point on your graph and tells you it's 10. If you wanted to find a value when x is 5, put 5 in for x and push enter, and it tells you it's at 137.5. You go to second, and then your trace button, because above it says calculate. And then the very first one says value, so push enter. And then you can find, it's like plugging in that x value, making your own table of values. So if you want to find out when x is 7, what's it equal to? 119.9. And it's a lot quicker than plugging it in on your own. Go back to your second calculate to this menu. Go down to the second one. Remember in our notes the other day, we talked about x-intercepts, zeros, and roots all meaning the same thing. So here they have 0 listed. That's going to find your x-intercepts. So if you want to find an x-intercept, let's say I want to find this one down here. Your calculator is going to ask you for a left bound. So first of all, I'm going to move that little cursor really close to the one I want to find. You don't have to do this every time, but there's the one that I want to find. It says go to the left of it. So I'm going to make sure that that little cursor, can you see if a horizontal line were drawn, that right now it's left of that x-intercept. Push enter. Some of the newer calculators draw a line. Is that line to the left of the one we want to find? It is, so you're good. Some of the other ones just have this little arrow at the top, so you won't be able, you'll just have to say, is that little arrow to the left of it? Yes, it is. Then it says go to the right of it, so I'm going to go past my x-intercept and go to the right of it. When I push enter, it draws another line. As long as your x-intercept is between those two lines, your calculator will find it. So then it asks you to guess, which just means you have to push enter one more time. And it finds it. It finds it at 10.4. Now this part here, if your calculator has like an e to the minus 11, that's scientific notation, that means it's at decimal 0.0000000 negative 1. Or 0, like that many zeros, 11 zeros before you get to your decimal. So it's basically at 0. But the calculator uses a process of getting closer and closer and closer. Eventually it feels like it's close enough and it stops. If you wanted to find the other one, so let's say I wanted to find the other x-intercept, I could go through the same thing. Second, calculate, go to number 2, which is 0. Now, to go to the left of that one, I'd have to push my thing over a number of times. It might take a little while, it might be a little annoying. Another thing you can do is if you can tell a number that is left of it, for example, can you see that negative 2 is left of that x-intercept? You can just type that in, negative 2, and push enter, and it will draw your line right there a little bit faster. And I know that positive 2 is to the right of it, so I can put my negative 2 and positive 2 that way. Yes? I chose 2 because I looked at my graph and could see that it was to the right of it. It would have worked if you chose 3 or if you chose 4. It didn't have to be 2. I just picked a point to the right of it and picked a point to the left of it. Is that x-intercept between those two lines? It is. So when I push enter, it finds it at negative 1.9. This time the calculator got close enough to 0 that it actually wrote y was 0. So that's how you can find your x-intercepts with your graphing calculator. The next thing on our list is minimum and maximum. What the minimum and maximum is really helpful for finding on a parabola is the vertex, because the vertex will always be either at a minimum if your parabola is opening up, or at a maximum if your parabola is opening down. The parabola that we have, you can see, opens down. So if we want to find the coordinates of that vertex, we're going to need to find a maximum. The same thing with the x-intercepts. You need to pick a point to the left and pick a point to the right. You can either do it with your cursor. So can you see that my cursor is already left of the maximum? I could push enter anywhere along here. So if I push enter now, my cursor is left of the maximum. Then I could go past it, and it doesn't matter as long as I'm past it, doesn't matter how far I'm past it. I could push enter anywhere once I've passed it. Or you could count and go 1, 2, 3, 4, 5, 6, 7, 8. I think when x is 8, and I type in 8, that would be the right of it, and that would work as well. Once you've got both again, it's going to ask you to guess. Just push enter again, and it finds the maximum happens when x is 5.102 and y is 137.55. So when you go second calculate or second trace button, those first 4 are the ones that we're going to use the most. Later on, when you draw 2 graphs, you can find out where they intersect. And numbers 6 and 7 you wouldn't need unless you're doing calculus. So the first 5 are the most important. And for us right now, we're going to use those first 4. So we need to know how to put something into our graphing calculator, how to adjust the windows either by using zoom or the window button to see what we want to see. And then we can find our x-intercepts, our maximum, which will be our vertex, from our calculator. So we'll learn how to do those things by hand, but sometimes the equation, like this one with decimals, it's easier to use our calculator to find them. Now that we found our maximum was what? I'll find it again quick. Our maximum, 2, 8, 137.55. Just drag that onto your notes. If we wanted to solve the last question that we didn't finish yesterday, which was asking the range if we wanted to find the range of this projectile got shot up in the air, it hit a maximum height, which we just found out now was 137.55, and then it came down and then hit the ground. So if you were asked to do a range of the parabola, you would say it would be everything less than 137.55 because that parabola would go down forever. But since we're in the context of a word problem, its range goes from 0, because that's when it hits the ground, up to the 137.55. That's interval notation. In set notation, you would say that your y values are in between 0 and 137.55. Did I give you the questions that you could do from this one the other day? No, I think the bell rang. Just question number 10.